The point P2 minus 3 is rotated about the origin through an angle of 90 degrees in an anti-clockwise direction. What are the coordinates of the image P? Now I will take this opportunity to remind you that you no longer have the option of running away from the topic of transformation matrices. Alright, in years past you would have been able to run away from that because you had options in section 2. You could have done 2 out of 6 and then 2 out of 3. Now it's 3 out of 3. So it is incumbent upon you to make sure and learn your transformation matrices. I'll just give you a short list of the ones you're supposed to know. Rotation of 90 degrees about the origin, rotation of 180 degrees about the origin, a rotation of 270 degrees about the origin. All of these rotations, of course, being anti-clockwise. You also have to deal with the reflection in the x-axis, a reflection in the y-axis, a reflection through the origin, and a reflection in the line y equal x, and also a reflection in the line y is equal to minus x. Now, I just want to say something in particular about the case of 90 degrees and 270 degrees. Starting with 180 degrees. If you rotate a point through 180 degrees, it doesn't matter whether you rotate it anti-clockwise or whether you rotate it clockwise, you'll end up at the same image point. So if you have to deal with a 180 degree rotation, you have one matrix. If you have to rotate through 90 degrees anti-clockwise, you'll end up at the same point as if you rotate through 270 degrees clockwise, and vice versa. If you have to rotate through 270 degrees anti-clockwise, you'll end up at the same point as if you rotate through 90 degrees clockwise. So in the special case of 90 degrees and 270 degrees, be extremely careful in taking note of whether the rotation is clockwise or anti-clockwise, because while the transformation matrices are given for anti-clockwise rotations, in the case of 90 degrees and 270 degrees, we could throw in a clockwise rotation just to add a little spoke in the wheel, right? To throw in a little spanner, so to speak, to make it think a little bit. And I will explain that in this same question that we're going to do here now. So we have in this question a 90 degree anti-clockwise rotation. So we have the transformation matrix for that, which is the matrix 0, minus 1, 1, 0. So 0, minus 1, 1, 0 will be the transformation matrix for an anti-clockwise rotation, right, of 90 degrees. Alright? You have the point P, 2 minus 3, 2 minus 3. Now remember from your transformation matrices topic that anytime you have a point P, a general point P, subjected to a transformation T, then the image of that point, let us call the image P dash, will be given when you multiply the transformation matrix by the coordinates of the point P. So in other words, we do what we call pre-multiplying the point P by the transformation matrix. In other words, we put the transformation matrix in front and then multiply by the point P. So if we have to apply that rule here, then the image of P dash would simply be, in this case, 0, minus 1, 1, 0, multiplied by 2 minus 3, which if we multiply, we'll get 0 by 2 is 0, alright, plus minus 1 by minus 3 is plus 3, and in the bottom we have 1 by 2 is 2, plus 0 by minus 3 is 0, so that the final answer would be the matrix 3, 2. So therefore, the image of P prime would be the point 3, 2. That is your answer A in this situation. But I want to go a little further in this question to change it up a little bit, switch it a little bit. Let us say, for example, they bring this exact question verbatim, except for the fact that they change the rotation from an anti-clockwise rotation to a clockwise rotation. So you could get the same question reading as follows. They could say the point P, let me use a different letter just for the sake of clarification in the video itself here, right? They could say the point Q, 2 minus 3, is rotated about the origin through an angle of 90 degrees in a clockwise direction. What are the coordinates of the point Q dash? Now, a 90 degree clockwise rotation is the same thing as an anti-clockwise rotation of 270 degrees. So, since we don't have a matrix for a 90 degrees clockwise rotation, what we do is use the matrix for the 270 degree anti-clockwise rotation. And that will give us the image of the point under a clockwise rotation of 90 degrees. So if we have a clockwise rotation of 90 degrees, let us see what space we could steal on the board here. The matrix for an anti-clockwise rotation of 270 degrees is 0, 1, minus 1, minus 1, 0. Right? So in black here, we have the anti-clockwise rotation of 270 degrees, which is the same thing as a clockwise rotation of 90 degrees. So you'll be using this matrix for a clockwise rotation of 90 degrees. This would be 90 degrees clockwise, which is the same as a 270 degree anti-clockwise, as opposed to here where you have 90 degrees anti-clockwise. This is the one that you would have more readily available. So in the case of the point Q, where we were subjecting Q to a clockwise rotation of 90 degrees, which corresponds to an anti-clockwise rotation of 270, what we will in fact have would be, let us see, try and steal some space over here now. What we will in fact have would be 0, 1, minus 1, minus 1, 0, multiplied by 2 minus 3, which would be 0 by 2 is 0, plus 1 by minus 3 is minus 3, and in this case you have minus 1 by 2 is minus 2, plus 0 by 3 is 0. So if it were a clockwise rotation of 90 degrees, which would correspond to an anti-clockwise rotation of 270 degrees, then the final coordinates of the point would be the point, let us say Q dash would be minus 3, minus 2. Alright, so be very careful of the differentiation between 90 degrees clockwise and 90 degrees anti-clockwise. Same thing for 270 degrees clockwise versus 270 degrees anti-clockwise. Of course, in the case of a rotation of 180 degrees, it matters not whether you rotate clockwise or anti-clockwise, you'll end up at the same point. Good? Now, just to reiterate that the specific case we're dealing with here in this question is answer A. That is the answer for the question, but I hope that you would have taken on board everything that I would have said in this question as a launch pad into your transformation matrices aspect of the question in vectors and matrices in a section 2.